fairly typical way, and you'll see this particularly on a lot of ceiling products, because ceilings really offer the largest area of absorption within a space. So, how else is sound transmitted around a space, and what can we do to stop it going from one space to another? Well, we can use a partition to do that, but you have to understand that when sound is generated within a room, the sound will, some of it will bounce back, some of it will be absorbed by a partition, and some of it will be transferred through. But if you've got sound which is, you know, footsteps like this on the floor above, a partition will do nothing to insulate from that. And there you need something fairly soft like a carpet or a soft floor covering to help absorb that impact sound. So like the sound absorption, it's possible to test a partition for sound insulation. And what they do here within the laboratory is that they test how much airborne sound will pass through a sample. So in order to be able to do that, they must be sure that the room itself isn't going to transfer any sound. So they're actually two independent rooms. There's a small gap between the two of them again. Let's just show you using this. So that is actually just insulation between two rooms, and it's a gap of probably about 100 mil, something like that. And they build this partition within the gap, they generate the sound, and what goes through is then picked up on the other side. And again, it's a before and after test, and that's how they're able to measure the sound reduction between the two. But again, the sound reduction is going to be dependent on the frequency of the sound, so you end up with a curve. And that curve then is compared against a series of standard curves to give what's called a weighted sound reduction index. You'll see that as dBRW. That's the weighted sound reduction index. And I've got an image here now actually of a sound test. So you can see here's the partition. The partition there has been built within the opening. And you'll notice there's no suspended ceiling coming through, because it's really just about the airborne sound transmission coming through the partition itself. And that will be sealed as part of the test, because any gaps around the edge is where you will get sound whistling through. If you ever want to hear a conversation going on a door, you'd go to an old-fashioned keyhole, because of course the sound will come through on that space. So again, a lesson early, when you come to look at partitioning and it being installed, it needs to be really as airtight as possible to make it as sound insulating as possible. I'm desperately trying to avoid the word soundproofing, because you can't soundproof a room, not really, possibly a recording studio, but avoid the word soundproofing if you can. The third method of control is diffusion. And diffusion is about scattering the sound. And that's used in auditoria, in atria, in classrooms. And it's really a series of quite hard surfaces, but at different angles. So back to the sound acting like light. You want it to bounce around. You want it to fill a space, exactly as you would expect to do in some sort of an auditoria or place like that. So that's covered the sort of basics of acoustics, a real snapshot of what sound is and how to control it. We're going to talk about noise next, and noise is just simply unwanted sound. It's the same stuff, but you just don't want it, and that's why we call it noise. And in fact, that comes from another word meaning nausea, and we know what nausea is. It's that sort of feeling of sickness that you can get from too much. Our recommendation in the whole of this process is that you should bring an acoustician in on a project, the same way as you bring somebody in to talk about data cabling and all of the other areas. And the first thing they'll do is to do a survey, a noise survey, and they'll want to know, where's the sound in the space before we start? We do nothing. You buy an airport. Are the lifts a bit noisy? What about roads? Is there structure-borne sound coming in? Will we affect the neighbours? Will the neighbours affect us? And then they'll start to look at what you're actually going to do within the space itself. Because only when you've got that information can you start to plan the spaces and put the right people in the right places. Within our guidance notes, we have a flow chart. And the flow chart is there to help you and your clients, anybody making a decision, to understand what the space is going to be used for and then how you can achieve that within the space. So the first thing to look at is what noise is in the space, and then what am I going to use the space for? Do I want privacy or do I want communication? Because those two things are actually different. If you're looking for an area of communication, you want to be able to stand in the corner of a room and talk, be heard by everybody at the back. So you don't want to be disturbed by outside noises. However, if you're looking for an area of privacy, you want to be able to have a conversation and be fairly certain that you're not going to be overheard, or if you can hear a conversation, you're not actually going to pick out words and sentences and not understand actually what it means. Now, all of these things can be calculated, and the acoustician will need to know all sorts of factors, what the background noise level is, so is there noise being generated by mechanical, electrical, what's likely to happen in the space, how big's the space, how reverberant is the space as well. All of that information needs to come together before the overall design can be pulled together. I mentioned that the largest area of absorbency within the space is the ceiling. It's uninterrupted. It's much better than the floor because the floor will have furniture on it and lots of other coverings as well. But the ceiling is generally uninterrupted. You may have the odd light fitting within it, but pretty much nothing else. Now, the ceiling itself can provide an awful lot in absorbency, but also insulation. So that is to say, if you've got a ceiling going over a space and you build a partition to the underside of it, it's like putting a cap or a lid on something. You need to ensure that that lid has also got the insulating values of the partitioning so that the sound doesn't go over from one side to another. Now, absorbent products tend to be soft, whereas insulating products tend to be quite hard and are full of mass. They're heavy. Ceiling products fall into a whole raft of different types of descriptors, from gypsum, plain and perforated, and steel, wet felted mineral fiber, resin bonded, mineral wool, glass wool, rock wool. They're all there. The softer materials, again, let's get this little cursor here. So the softer materials through here tend to be the best for absorbency, whereas you can see the harder products here tend to be best for insulation. But the manufacturers themselves are able to mix products together, so it is possible to get a product that really you would expect to have a high absorbency rate that can also have high levels of insulation. So if you're going through a design process, it's worth talking to the manufacturers about the performance requirements of the products that you're actually looking for. My cursor seems to have stopped working. Okay. So privacy is an important factor as well as of absorption within a space. And if I want to have a private conversation, I mean, one of the things I could do here is turn a radio on, and it would be quite difficult for you to hear me above that background sound. So you can use the background sound to help mask a conversation. But it's also possible to use a partition in concert with a background noise to mask the conversation. And there's a broad mathematical measurement of working out the speech privacy potential, the SPP. If you measure the background noise level and add it to the performance of the partition that you're going to get on site, if those two figures are about 75 or more, you will achieve privacy. Below that, it would be hard to achieve privacy. So that also suggests that in areas of privacy, you really want to put them in quite a noisy part of the building, or introduce noise. And you'll sometimes go into a dentist and they've got the radio on, or you go into a reception area and they've got the television on. Part of that is there not just to make you feel welcome, but it's also actually there to help mask some of the background noise as well that's going on. Good, got that working as well. So again, another one of the tables from our design graph, which shows the performance of a partitioning running from low to high, and the background sound level, again, running from low to high. And if you put those two things together, so if you've got a partition that's really quite low in terms of sound performance against a product here which is a sound which is quite low, you're not going to achieve privacy. But likewise, if the background noise level increases, then you're going to get better levels of sound performance. So it is possible to actually value engineer a partition to achieve levels of performance and at the same time actually save you some money as well. So to help you look at some of the different partition systems that are available, we've listed them here. So you can see from a very simple 50mm bonded board type construction through to the heavier operable walls, and then comparing that with a 100mm blockwork wall, you can see that taking 100mm blockwork, there's a whole range of partitions actually that can achieve the same, if not better, than a blockwork wall. So it is possible to achieve good levels of sound insulation from a whole range of products without necessarily having to build a blockwork wall, which is quite often the default. So what can go wrong?